Assalamu alaikum everyone. Now today we discuss about the properties of matter. As earlier we described the chapter theory, now we are moving towards the chapter numerical. So dealing towards first numerical of the chapter. So the mass of 20 centimeter cube of stone is 500 gram. Find its density. So how to find this? As the value of mass, the mass is 500 gram. Okay, and the volume is 200 centimeter cube. Find the density. As density is equals to mass by volume, so density equals to 500 gram divided by 200 centimeter cube. So density equals to 2.5 gram centimeter per cube. So this is how to find the density, simply by putting the formula of density, as density is equals to mass by volume. Now putting the value of mass and the volume, we find the value of density. Now in second question, a hydraulic press, a force of 100 Newton is applied on the piston. Of cross-sectional area is this. As I am taking this F1 equals to 100 Newton and the area A1 equals to 0.01 meter square. Find that the find the force that compresses a cotton bale placed on a large piston of cross-sectional area of 1 meter square. So we have to find F2. Okay, and the area 2 is given 1 meter square. So how to find the area 2? As we know that the pressure on piston, smaller piston, this one, equals to F1 by A1. Now putting the value of F1, that is 100, and A1 is 0.01. So pressure equals to 10,000 Newton meter per second. Okay, now we have to find the pressure on F2, this body. So pressure equals to F2 divided by A2. As the value of pressure is given, we have to find the value of that is 10,000. Now putting this 10,000 in this equation, and we'll find the value of F2. So F2 must be equal to pressure multiplied by A2. So what is the value of pressure? That is 10,000 multiplied by area 2 is 1. So it's equals to 10 kilo Newton. Okay, this is the second numerical. We have to find the F2. So first we have to find the value of pressure, then we have to find the value of F2. So this is the end of this numerical. Now in the third numerical, the values given are now a wooden cube of size 10 centimeters each has been dipped completely in water. Calculate the upthrust of water acting on it. So first we have to draw a diagram to understand the correct representation of the whole system. This is my beaker filled of water. This is all the droplets. Now The wooden block, wooden block, this is the wooden block. Now, what it carries, that is its weight, W, weight, that is the, now at the upward, that is upthrust force, upthrust force, and the total distance, that the total height of the block is 10 centimeters. 10 centimeters. So we have to calculate the upthrust, this force. We have to calculate the upthrust force. So for doing this, we know that according to Archimedes principle, upthrust of water equals to rho GV. Upthrust of water equals to rho GV. Now we have to find the value of rho, G, and V. As the value of rho, that is density of water, that is density of water, it must be equals to 1000 kilogram meter per cube. Okay, the value of G is 10 meter per second square. And the volume, now third is volume, as this is a cube, so volume equals to length multiplied by length multiplied by length, that equals to length whole cube. Value is 10 centimeters and meter is 0.1 meter whole cube, and it must be equals to 1 into 10 to the power minus 3 meter cube. Now just putting the value, that is upthrust of force, upthrust of water is upthrust of water equals to rho multiplied by G multiplied by V. Now the value of G is rho is 1000, value of G is 10, and the value of V is, that is volume, is 1 into 10 power minus 3. So after summation, this value equals to, that is the force, upthrust force equals to 10 Newton. So this is how we find the value of upthrust force systematically. This is the diagram which shows there, and this is the value. Now putting all this, and this value equals to 10 Newton. Now moving forward, the next numerical is the weight of a metal stone in air is 0.48 Newton. Its weight in water is 0.4 to find its density. If there is a comparison in densities, if there is a comparison in densities, then density equals to W1, that is the weight of the first. Now W1 minus W2 into rho. This is a formula to find if there are two weights. Okay, so W1 equals to weight of spoon, weight of spoon in air. Okay, and W2 is weight of spoon in water. So W1 equals to 0.48 Newton, and W2 equals to 0.42 Newton. Now just putting this, and the raw value is 1000 for water. So it's equals to 0.48 divided by 0.48 minus 0.42 multiplied by 1000. So this whole equals to 8,000 kilogram meter per cube. This is the value of density. This is how we find the value of density. Now, the next numerical is an empty metallurgical balloon weighs 80 Newton. It is filled with 10 cubic meters of hydrogen. How much maximum content the balloon can lift besides its own weight? The density of hydrogen is 0.06 kilogram meter per cube, and density of air is 1.3 kilogram per meter cube. So how to start this? As W, that is weight, equals to 80 Newton, volume is 10 meter cube, rho 1, rho h equals to 0.09 kilogram meter per cube. So first we have to find the weight of hydrogen. So how to find weight of hydrogen is, so weight of hydrogen is weight of hydrogen to find, okay, to find. Now rho 2 is equals to density of air equals to 1.3 kilogram meter per cube. So the upthrust force, that is F, equals to, now for air, and this is for hydrogen, and this is for air. So in this case, F equals to, for upthrust, rho 2 into G into V. What is the value of rho 2? 1.3. Value of V is 10. Value of V is 10. So it's equals to 130 Newton. Now weight of hydrogen. So weight of hydrogen is W1 equals to rho 1 V into G. So how to find rho 1? Rho 1 is 0.09. V is 10. G is 10. So omega 1 equals to W1, weight 1 equals to 9 Newton. Now total weight must be equals to W1 plus W2 plus W. What is the value of W1? W1 equals to 80 Newton. W2 equals to 9 Newton. And W2 equals to W2. And this is force, that is force, upthrust force is F. So this is equal to 89 Newton plus W2. We have to find the W2, and the value of force is 130 Newton. Putting the value there, 130 Newton. So W2 equals to 130 minus 89. So W2 equals to 41 Newton. This is how to find the W2. First, we have to find the upthrust force. Then, now the total weight is W1 plus W2 and the W. The W given as 80 Newton. This is the value, 80 Newton. W1 is 9 Newton. We have to find W2 equals to total force. Total force is 130 Newton. So putting the value there, W2 equals to 41 Newton. That is 41 Newton. Now, the next numerical is a barrage 40 meter long, 8 meter broad, and the vertical is 12,000, 1 lakh 25,000 Newton of cargo is added. How many meters will it sink? So first is how to find the area. Area length multiplied by breadth. Area is 320 meters square. Now additional load. Additional load is this one. Load is 125,000 Newton. Now, as we know that the upthrust force is rho GV. Okay, and the second, we know that the force must be equals to its weight. As force equals to rho GV and the force equals to weight. Now compare both equations. That is W equals to rho GV. Okay, now putting the value of W is 125,000 equals to the value of G is 1,000. So the value of rho is 1,000. We have to find the V, and the value of G is 10. So V equals to 125,000 divided by 1,000 multiplied by 10. So the value of V is 12.5 meters square. We have to find the depth, that is how much meter it adds. So H equals to, that is the volume divided by area. H equals to V by A. So H equals to 12.5 divided by area is 320. So this is meter cube because of volume. So H equals to 0.04 meters, which is equals to 4 centimeters. So this is the method to find this. The complete procedure is here. So we have to find the H. For H, we have to find first compare the two equations of forces. So we find a relation, then we find the value of volume as the value of H equals to volume by area, that is H equals to V by A. So from this relation we find the value of H. Now the last, a steel wire is long as cross-sectional area is, now the area given as 5 into 10 raised power minus 3 meters square through 1 mm. That is the change in del L equals to 1 mm, which must be equal to 0.0 meter. Then the original length is, that is, original length given is 1 meter. Original length is 1 meter. And the force is, that is, force equal is 10,000 Newton. Find the Young's modulus, as Young's modulus equals to F by A and whole divided by del L divided by del naught. So Y equals to F L naught del L into A. The force equals to 1000. Del L is 1. Real naught is 1. Del L is 0.001. And the area is 5 into 10 raised power minus 5. So by putting this, we have to find the Y equals to 2 into 10 raised power minus 11 Newton meter per second. This is the method to find the Young's modulus. That Young's modulus equals, this value is, as this value is stress, and this is value of strain. So Young's modulus is the ratio of stress plus strain, as stress equals to force by area, and the strain equals to change in length divided by original length. So we find the Young's modulus. That's it from this lecture. Hope you are understand each and everything. Goodbye from this lecture. Allah Hafiz.